All right, this quick little tutorial is going to show how to look at a pedigree and know that it's dominant, and then how to assign those genotypes to each member of this family, looking at inheritance patterns. So when we look at this pedigree, the first thing you want to notice, again, is that there's 1, 2, 3, and 4 generations in this family. Now, when I look at that, every single generation has some shading. So really you could go and you could look at that one's shaded, this one's shaded, this one's got some shading in it, and then the final one has some shading in it. Now I'm just going to erase all of those, but when you look at this and you see, where's my eraser? Whoa. Oh my gosh, what am I doing to this thing? When you look at this and you see that why will it not let me shade that out? Oh my gosh. When you see that there's shading in every generation, this is for your entertainment apparently, then you call it a dominant pedigree. Okay. So, because there's shading in every generation, we're going to call it dominant, okay? That means that the dominant letters are going to go on the shaded ones. So, number 1, we can already answer that this is based on dominant traits. B. What evidence support it? It's the fact that it occurs in all generations. C. How many generations? Well, when I wrote that out before I completely messed up the page, there was 4 on there. How many males have the condition shown in the pedigree? Remember, males are going to be represented with squares. Females are represented with circles. So when I look down here, I see 1, 2, 3 males that have the shading. Okay, how many marriages are represented in the pedigree? Marriages, keep in mind, are going to be represented by that line, horizontal line in between. So when I look at this male and female were married or reproducing. This right here, 2. This is 3. Down here's 4. And then here is 5. So then you would go and fill that answer in as 5. Okay, now we said the dominant gets the shading. That means that every shaded shape is going to get a large uppercase letter. So let's use A's again, okay? We'll put an A there, an A there, an A there, 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 and there. Now what this means right away is that you all of a sudden know that, well, if the shaded ones are dominant, that means that the non-shaded boxes are going to get that homozygous recessive, the 2 little letters. So you can go and put all of those on your tiny non-shaded shapes, boys and girls. Okay. So we just have those capital letters, but sometimes you can figure out whether or not they would have had to have been heterozygous. So let's look down at our bottom, okay? I'm going to work right here on this double little a. The only thing this mother can offer to her child is a small a because she's got 2 of them, okay? Do we know what the father would have been? He could have been big A, or big A, little a. So we just put that A hyphen there. We don't know. Now, this guy that we just gave that hyphen to, his brother next to him was 2 little a's, which means that one of those a's, I'm going to write here in blue quick just to change it up. One of these little a's came from his mom, and one of these little a's came from his dad. So this little a came from here. The other one had to have come from his mom. So we can put that on there. Now let's go over to the left and we're going to work, it's really hard for me to point out where I'm talking here, these 2 little a's. She's got 2. one came from her mom and one came from her dad. So writing in blue, that's going to tell you that one of these little A's came from her mother, sorry. Okay, now let's go and look down. Right where we circled in yellow there, that female with the homozygous recessive little A's, look at their two daughters. The only thing that mom can give to her daughters is a small a. So we know this is a small a here from mom, and the other daughter would also have to get a small a. Okay, so then let's look at dad. If dad has that, we can look at this daughter again who has two A's and know that one came from mom, the other one had to have come from the father. Okay, so a lot of times it's really easy to look at the recessives and split them either up. If they have two, you can know that one came from mom and one came from dad, as well as looking down, knowing that those homozygous recessives or those little A's can only offer to their offspring one of those little A's, because that's all they have. And this would be how you do dominant. Okay, this is a dominant pedigree because we see shading in every generation.